continuous random variable. Let's look at another example of a distribution function. I'm gonna focus on the normal distribution here, and that's because if there's one continuous random variable that we need to understand and understand really well, it's the normal distribution. We're gonna get back to why. The idea is that whenever we look at average effects, the average effects will always be normally distributed. And this is such a powerful result because it means that no matter which distribution the random variable originally was, when we look at the average effect of the random variable or the average of the random variable, that will always be normally distributed, which means that we will always know the distribution of an average effect. So, as previously, we're going to assume that our random variable x follows a distribution, in this case the normal. Note here that the normal distribution is given by two parameters. The first one is the centrality, where is the center mass, which is denoted by the Greek letter mu. The other parameter is the spread, which is the variance, which is denoted with sigma squared. So this means that if we just know mu and sigma, then we know everything we need to know about this random variable, if it's normally distributed. So instead of needing to know exactly the whole probability space, we only need to find two parameters to describe the whole random variable. So the mu is the center mass, the expected value of this random variable. So that means if we pull a lot of examples from this random variable, where will most of them end up? Very close to mu, the expected value of that distribution. The other parameters, sigma squared, is the so-called variance, the square deviation from the expected value. In practice though, we usually do not discuss the variance. We usually discuss the so-called standard deviation, which is the average deviation around the expected value. We're gonna soon visit these concepts and actually start calculating them and using them. So don't worry if this is just a lot of symbols right now. Very soon we're gonna put it into practice and everything gonna become much clearer. But first, let's visualize the normal distribution because we're gonna see it all over the place when we work with statistics. So one classic variable that is normally distributed is the IQ score, the ability of people. And why it's normally distributed? It's because it's constructed that way. You take a lot of test scores and then you normalize them. So you get the normal distribution. And for IQ, the mean, the center mass, the mu, will always be 100. And the average deviation around the mean gonna be 15. And since the normal distribution is defined with the variance in mind, we need to square that to get the second parameter, the variance. So let's visualize this. So notice here we have the IQ score on the x-axis. We have the center mass, which should be the mean, the mu, the expected value, which should be 100. And then we have an average deviation of 15 around this mean. It means that most people gonna have an IQ somewhere between 85 and 115, meaning the expected value plus minus the standard deviation. Another thing we can do with the normal distribution and why it's such a powerful concept is that we can start asking what is a reasonable value? What are extreme outcomes? So for example, if you want to join the Mensa club, then you require an IQ that is above 135. And as we know, that is a very extreme value. Very few people in our population will have an IQ above 135. To evaluate how extreme this is, then we can just take the gray area, the size of that, and compare it with the orange area. And what we note is that very few people will be in the orange area. So that means an IQ above 135 is very unusual in the population. Another thing that you're gonna get here is that you can quickly evaluate the reasonable of people's statements. So if somebody would come up to you and say, oh yeah, I have an IQ of 250, you're gonna directly know that that is such an unlikely event, meaning that 250, it doesn't even exist on this scale, that he is either lying or there's something wrong with his test score. And that's the nice thing when we have the distribution function. It's very simple to evaluate what is a reasonable outcome and what is an unreasonable outcome. And even more, we can even start asking ourselves, where is the cutoff where we go from a reasonable outcome and an unreasonable one? Now we have looked at a continuous random variable, the IQ score. And I have focused on the normal distribution because if there's one continuous random variable, one continuous distribution function that you're going to see all the time in statistics is the normal distribution. So you need to start loving the normal distribution because no matter what you're doing in statistics, there's gonna be a normal distribution somewhere in your calculations. So next, we're gonna start looking into how do we calculate the expected value and the variance.